I received a request for help with this problem, which is 12.1, number 26 from the study plan. Of course, who knows what it is in your homework, and I'm going to do it with you. Okay, so I'm actually going to use the example, but of course the idea is the same for both. All right, so statistical software and graphing calculators with advanced statistical features use random number generators to create random numbers conforming to a specified distribution. Use the list of randomly generated numbers from 1 to 5 presented in the table. Complete parts A and B below. Okay, so let me just click on this. I'm going to copy it to my clipboard. Now, I could copy it to StatCrunch, but you actually have to tweak this a bit before you can put it into StatCrunch. So I'm going to put it right here. Paste. All right, cool. And if you'll notice, by the way, there's 50 numbers there. It's a 10 by 5 table. All right, so assuming the random number generator is generating numbers with equal likelihood, so saying that they're all got the same proportion, what proportion should be generated for each of the 5 numbers? So let's go back here. All right, the null would be that the proportions are all equal to 1/5, right? Which is 1 divided by 5. 0.2, because there's 5 numbers there and 1 divided by 5. Like if there were 8 numbers, it'd be 1 divided by 8. Okay, so then that helps you figure out your expected value, because if you expect them to all be 1/5, it's 1/5 of what exactly? Well, actually, let's do this a couple ways. First, let's find the observed. I want to know how many of each cell there were. So I'm going to do A1 colon A50. I'm going to give them both dollar signs because I don't want them to change as I drag this formula down. Comma 1. How many ones did I have? Oh, I don't want to do 1. I'm sorry. I'm going to do the cell reference. That way I can drag. So again, A1 and A50 get dollar signs because I don't want that array to change at all. But I want C2 to change. I want it to become C3 and C4 and so on. So I'm going to click and drag. Now if I did this right, when I add these up, it should become 50, which I could tell is what it would be if I did down here, because you can see that it ends at the 50th row. You can also see it down here in the bottom right corner. It says the count is 50. That means there's 50 cells in there. All right, let me scroll back up. So now that I know the total is 50. The expected value is the null hypothesized value, pi, 0.2, times that 50, and give it dollar signs. That way when you drag it down, it doesn't change. Oops. Oh no, I don't want that to change either. Hold on, I did it wrong. I don't want either one of them to change, right? Because this one doesn't change. If it was something like I expect one to happen 0.2 and the next one to 0.1 and the next one 0.3 and so on, then I would actually take 50 times that and then 50 times the next one and then 50 times the next one and so on. But since for us the null hypothesis is that they're all equal, then these numbers should be all equal. Okay, cool. Now I've got my observed and my expected. That's what I needed to be able to paste into StatCrunch, which I think I have open somewhere. I guess I lost it. That's okay. I'll get into it. Oh, let me make the font bigger. Hold on. Okay, there we go. So I got my observed and my expected pasted in there, and then I can do stat goodness of fit chi-square test. Now my observed are in the observed column. It's kind of crafty how I name them that, right? Expected are in the expected column. Let's go to calculate, and I get this guy right here. I'm going to copy and paste that. Hold on. There, edit, copy. Let's go in here and let's paste. There we go. Cool. All right, now let's see if this all matches up. Because I did all of this. Let's see if it matches the instructions. All right, so they're going to get 0.2 for everything because we said the null hypothesis that they're all 0.2. And then chi-square statistic. Let's see if we got ours to match that. There it is. Chi-square statistic is 4 on this one. Cool. And then the p-value is 0.406. Yep, that's what we got to. And that's a high p-value, so we're not going to reject the null hypothesis. All right, so it doesn't seem like this particular random number generation was loaded. Right, it seems pretty fair because that's a high p-value. Right, so if you want to think of it this way, the null hypothesis is that the random numbers are random, right? Or they follow or are all equally likely, right? Because if the proportion's 0.2 for each one of them, that's equal. The null is that they're not all equally likely. Or excuse me, the alternative is that they're not all equally likely. If we don't reject that null hypothesis, then we're saying, yeah, we didn't have enough evidence to prove that they were not all equally likely, right? We didn't have enough evidence to prove that it was not fair or loaded. All right, we're all done with that one. I hope it helps.